Let's consider this parallel circuit with a source voltage of Vt and three resistors in parallel, R1, R2, and R3. When connected, a current will flow from the battery, and we will call it current I, which is the total current flowing, and it will be split into three currents flowing through the three resistors, the magnitude of which depends, of course, on the values of the resistors. Ohm's law tells us that the total current will be given by the supply voltage divided by the total parallel equivalent of the resistors that are parallel in the circuit. The equivalent parallel resistance can be calculated using this equation, where 1 over the parallel equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now let's take a look at calculating the current I1 through resistor R1, which we can calculate using this equation. I1 is equal to Vt divided by R1. If we didn't know the supply voltage but did know the total current, we could calculate Vt using this equation. Vt is equal to I times the parallel equivalent resistor, which is just another form of Ohm's law, which we can now substitute into our equation for I1. This tells us that we can calculate the current flowing in R1 if we knew only the resistance and the total current flowing through the circuit. The current flowing in R1 is given by multiplying the ratio of the equivalent resistance divided by R1 times the total current. We can generalize this equation by calculating the current flowing in any of the parallel combinations by dividing the equivalent resistance of the parallel combination by one of the resistors, which we will call Rn. The current flowing in Rn is given by multiplying the ratio of the equivalent resistance divided by Rn times the total current. This is known as the current divider. Stay tuned to this site as I'll be diving into more information on electrical subjects from my courses. In the meantime, take advantage of the availability of my free 50-page electrical power crib sheets, if you don't already have them downloaded. Simply fill out the information requested when you go to this website, https:// bit.ly/47 uppercase y uppercase b 3 lowercase v and lowercase h. You can also directly access my StanStore courses at this website, https://stan.store/uppercase G, uppercase V, and uppercase B.